I look bald. Anywho. Closed-toed shoes. Goggles. Hair tied up. Oh yeah, no long hair in here. Alright, so right now Macy is filling up the cuvettes with our stock solution. So she is filling up the first one to, there's like a line right like there, and let's see. Oh, and stoppish maybe? Yeah, there we go. Looks good. Take 15 of zeroing it in. Here we go. Here's the blank.
And then show.
Thoroughly wiped. Expertly placed.
Be careful.
Thoroughly closed. And
Almost perfect.
zeroed. Alright, so right now Macy is cleaning off the stock solution so we can run an all wavelength test to see what wavelength is best for the absorption. Whatever that is. Copper something.
Copper mean.
Copper, yeah, copper mean, thank you. Alright. So, just gonna save that. Yeah, name it something, like coolkids.com.
Stop.
We're not.
Okay.
Okay, well, there we go. Now we're going to begin right? And if we stand, okay, stand to go to the top of that little like thing over at the top. Not like this, but if we, okay. Now okay, now it's reading the wavelengths. Oh, there we go. Okay. Aha, so the peak looks to be around almost exactly 600, so that's like the max absorption done by the wavelength scan. Was it around 600? So that's what we're going to be estimating, or that's what we're going to be using as our precise wavelength for all the other stocks. Let's go get it. So here's the setup, and she's changing it to 600 because it's the wavelength that we decided.
Ooh, gentlemen.
Oh yeah. Gotta really carefully do this. Can't let a smudge ruin our results. Alright, here's the taking it out. Look at it go. Carefully. Carefully.
And this is our first dilution from the stock.
Yes, here we go. And the correct sides are facing. Alright. Closing it politely. Alright. Bringing it. Oh, okay. We have, I write down value of point.
02080.
Don't leave your chem wipes. Put it in the trash. Put it in the trash. The trash. Oh.
Once you're done in the lab, make sure to clear all your materials, even the software you use,
Yeah.
so other labs can use it as well.
Slay. There we go. This way. Now as we demonstrate the correct way to clean up our lab space, I'm going to tell you all about Beer's law. It is represented by this equation where the A stands for absorbance, the epsilon is a constant, the L is the path length, and C is for concentration. A and C are both variables in this equation, and they are directly proportional. The concentration was determined through measurements taken in the lab using N1V1 equals N2V2. The absorbance was measured using the spectrophotometer, where the instrument would calculate the percentage of light the solution absorbed by determining how much light it is censored behind the solution. It is important to zero the spectrophotometer before using by placing a blank into it. This makes sure the machine doesn't pick up the absorbance by any other factors such as the water molecules in the solution, and that it only calculates the light being absorbed by the copper amine. Failing to zero this machine would likely lead to higher absorption readings.
Amazing. We already know that, and I'm going to explain lambda max to you. So lambda max is the wavelength at which a substance has the highest absorbance of photons.
Woo! And that will be seen at the peak of a graph.
Indeed.